Section 7-6, angle measures and segment lengths. Our lesson objectives today for this lesson are to find the measures of angles formed by chords, secants, and tangents, and to find the lengths of segments associated with circles. Let's actually take a look. We have a new vocabulary word here, and this one in particular is what is a secant. A secant. A secant is a line that intersects a circle at 2 points. Here we have, on the right here, we have circle O, and we have line AB, and line AB intersects the circle O at precisely 2 points right over here. So because it intersects my circle at 2 points and goes beyond the circle, it doesn't end there, it goes beyond, therefore a line. That is what makes it a secant. You could also say that you have a secant segment, but the segment needs to actually go beyond the circle. So my endpoints are over here. I'm just going to say this is point C, this is point D. You can actually have secant segments as well, but the endpoints of the segment cannot be on the circle. That is a secant segment right there. All right, moving on to our first theorem. All right, Theorem 715 states the measure of an angle formed by two lines that, case 1 is intersects inside a circle is half the sum of the measures of the intercepted arcs. So if we take a look at the little diagram here, we have arc X and arc Y, and we have an interior angle right over here, angle 1. And the relationship between those arcs and that angle is that we know that the measurement of angle 1 equals 1/2 x plus y. Right? If you're inside the circle, the angle is inside the circle, that's the relationship that we use. That's case 1. Case 2, intersect outside a circle is half the difference of the measures of the intersected arcs. Now we have 3 cases that we can actually take a look. We have 2 secants on the first image here. We have a secant and a tangent, and we have 2 tangents. Either case will work. So for this particular case, we would say that the measure of angle 1 equals 1/2 the difference, x minus y. Okay? So one easy way to remember which is which, well, if the angle is inside, you add. If the angle is outside, you subtract. So that's the easiest way to remember which is which. All right, let's take a look at some examples. All right, example 1, part A, number 1. It says to find the value of each variable. In this particular case, number 1, we're looking for an angle inside the circle. So we have case 1, inside the circle. So I can say that x equals 1/2 the sum of my arcs. One arc happens to be 46 degrees, and the other arc happens to be 90 degrees. Then we go ahead, actually this is because of Theorem 715, case 1. All right, so then we go ahead and simplify. So we get 1/2 times 136, and that gives me 68 degrees. That's the answer for that one. Now for the other one here, number 2. Number 2, this is case 2 because the angle here, the 20-degree angle is outside the circle, but we're not calculating the exterior angle or anything else. We're calculating this arc right here, Z. So we still can use case 2. It's just that we had to do some minor algebra to solve it. So here's what we do. We know that that exterior angle is 20. So we say it's 20. equals 1/2 times 95 minus z. All right, and that is because theorem, actually write theorem 715, case 2. So we have here, now it's just algebra. So we have here a fraction of 1/2. I want to get rid of that fraction of 1/2 before I keep solving it. So to get rid of that 1/2, I just multiply everybody here by 2. So on my left, I end up having 40. And on the right hand side, I'm just left with the 95 minus z. That looks like an S, doesn't it? So I'm going to make this a 5. All right. Then we go ahead and rearrange the equation here. So it reads z equals 95 minus 40. So z equals 55 degrees. And that's what we get. All right. All right, part B has 2 of them. So still, you're going to have to find the value of each variable. All right. You have 1 and 2. So give this one a shot. Pause the video and see if you get the same answer that I get. Good luck. All right. So here's what we actually do. In this particular number 1 here, the angle is outside this that they gave it. They actually give us the angle. So we're here in a case 2, right? So here's what we have. We know what the angle is. So the angle is going to be 70, and this equals to 1/2. All right, and that is 1/2 times the quantity of W minus 110. Okay, so now that we have that, and this is true because of theorem 715, case 2, then we go ahead and distribute, actually not distribute, we have that 1/2 here, so we're going to get rid of this 1/2 by multiplying both sides by 2. So we get 140 here, and that the 1/2 disappears, leaving me just with the W minus 110, which then if we add 110 to both sides, we end up having W equals 250 degrees. All right? Hopefully that's exactly what you got. All right, let's take a look. Number 2 also uses case number 2. So we can just say that y equals 1/2 times 110 minus 30. Okay, so this gives me 1/2 times 80, and 1/2 of 80 happens to be 40, and that is 40 degrees because y is an angle measured in degrees, and there is that one problem. Hopefully you got the same answer that I did. All right, moving on. Here we have this problem. And the diagram here on the right, and it says this. You focus your camera on a fountain. Your camera is at the vertex of the angle formed by the tangents to the fountain. You estimate that this angle is 40 degrees. What is the measure of the arc of the circular basin of the fountain that will be in the photograph? So we're trying to find out what that angle or what arc that is. So we make this drawing right here in which we know that the angle formed. Here's our camera here, and we have two tangents. So the angles that we have for reference are outside the circle. So we're going to be using Theorem 715 case 2. All right. So here's what we actually do. Notice now that there is no value for this arc over here, and the other arc, we have no idea what that is. We just know that this angle here is x. Well, actually, this arc here is x, and the exterior angle is 40. So how do we do this particular problem? Well, we'll get there in a second. All right, so here it goes. We have that 40. Actually, let's make some relationships first. We know that the measurement of arc AB is x, right? AB, see, my endpoints of that arc are AB, so the arc can be called AB. And we know that the two arcs together form a full circle, and that circle measures 360 degrees, right? So we can say that the measurement of arc AEB, and that is AEB right over there, equals 360 degrees minus whatever that piece of arc here labeled x. So it's going to be 360 minus x. Okay, so now we go ahead and set that up. The exterior angle we have that is 40, and that equals 1/2 times the quantity of 360 minus x minus x. That's what we have there. We go ahead and start simplifying here by combining like terms inside the brackets. So we have 40 equals 1/2 360 minus 2x, right? We have minus x over here, minus x here, gives us minus 2x. So over here, I want to get rid of that 1/2, so we multiply both sides by 2. So we get 80 equals 360 minus 2x, right? Because I don't like dealing with negative variables, I'm going to rearrange this equation by adding 2x to both sides and subtracting the 80. In other words, this is going to end up looking like this. It's going to end up looking like 2x equals 360 minus 80, which then gives me 2x equals 280. Then we divide both sides by 2, and x equals 140 degrees. So the measure of the arc right here that will be seen is going to be 140 degrees. Okay? Now let's see if I can move this so you can still see it, because part B uses the same diagram. So take a look at the diagram, and here goes. To photograph a 160-degree arc of the basin, should you move towards or away from the fountain? What angle should the tangents form? Give this one a shot. Alrighty, so in this case, instead of finding whether we're moving towards or away first, we need to find out what the angle of that angle happens to be first. So we're actually going to go ahead, since we don't know what the angle is now. We no longer know this angle. I'm going to call that point C. Okay? Then I'm going to use the property that we just learned, because it's an exterior angle. So this is a case 2. So we can say that C equals 1/2 times 200, right? 200 minus 160. And that actually comes because I know that the measurement of AB is now 160. And I know that the measurement of AEB is 360 degrees minus 160, which gives me the 200. All right? That's where the 200 came from and where the 160 came from. So now that we have that, that equals 1/2 times 40, which gives me 20 degrees. So the question is, should I move away or towards? Well, here's the thing. If you move away, this angle has to close. It has to close. If I take this vertex right here and I pull it in this direction away, the angle has to close. So that makes it from 40 degrees to 20 degrees. So that's what I actually would do. So the answer here is we need to move away. All right. Very good. Moving on. We have Theorem 716, and there are 3 types: type 1, type 2, and type 3. So Theorem 716 states, for a given point and a circle, the product of the lengths of the 2 segments from the point to the circle is constant along any line through the point and the circle. That's a mouthful to say, but here is what it actually means. So for type 1, here's what we know. We can say that the product between A times B equals the product of C times D. That's true for a type 1, which is just 2 secants. 2 secants. If I have 2, actually, these are 2 chords. If the intersection of 2 chords, not 2 secants, 2 chords, we can actually use this relationship to find that. Now, type 2, we actually have a couple of segments that extend outside the circle. So here goes. We have this relationship states that W plus X times W equals the quantity of Y plus Z times Y. That's for a type 2. For a type 3, we have a secant and a tangent. We have a secant and a tangent. So type 2 was 2 secants, type 3 is a secant and a tangent. So in this particular case, for type 3, we have Y plus Z times Y equals T squared. And there we have that one. So that is Theorem 716, types 1, 2, and 3. Okay, now let's take a look here at some examples. And let's take a look. All right. Number 3, finding segment lengths. Find the value of the variable. If the answer is not a whole number, round to the nearest tenth. So let's take a look. On this one right now, it meets the criteria for Theorem 716 type 2. We have 2 secants. It goes right here, outside the circle. The point is outside the circle, so it intersects my circle on 2 points. This one does, and that one does. So we have 2 secants. So we can actually say that we have the quantity of 6 plus 8 times 6 equals the quantity of 7 plus y times 7. And reason for that is Theorem 716 type 2. So we have this is on the left is 84. When we distribute this over here, we get 49 plus 7y. Then we move the 49 to both sides, and we get 35 equals 7y, which then gives me that y equals 5. And since we don't know what those units are, it doesn't say they are meters, centimeters, or inches, is a length, so it's 5 units. 5 units. Okay? Alrighty. Now for number 2 we have a type 3 because we have a secant and a tangent. As you can see, z represents a tangent, and this one right here is a secant. So for this one, for type 3, in that case, we're going to say that this is going to be z squared. I'm just going to put z squared on the left-hand side because that's what we're going to be solving for. Z squared equals the quantity of 8 plus 16 times 8, which gives me 192. So z squared is 192. So we can go ahead and take the square root of both sides, and we get that z equals the square root of 192. And this equals 13.856 ... because it keeps going. Because it says to round it to the nearest tenth, then this is approximately equal to 13.9. And again, it does not say what units, but it's a length, so it will say 13.9 units. And that's our answer right there. Okay. And part B. Part B has 2 problems for you to do. So take a look at the problems, actually at the diagrams. It says to find the value of the variable to the nearest tenth on number 1 and on number 2. Good luck. Alrighty. So on this particular case, we have here on number 1, we have a type 1, actually a type 2 rather, a type 2. So we have 2 secants and an angle outside. So we can say now here that we have the quantity of the quantity of 14 plus 20 times 14 equals 16 plus x times 16. That's because of the theorem 716 type 2. When you do the homework, you don't actually have to give me the type of theorem that you're using. You don't have to justify it. I just need to see the steps. So on here, on the left-hand side, that simplifies to 476 equals 256 plus 16x, that's a big plus sign, plus 16x. Then we go ahead and subtract the 256 from both sides, and we are left with 220 equals 16x. We go ahead and divide both sides by 16, and we get that x is equals to 13.75, which is approximately equals, because it says to the nearest tenth, this is approximately equals to 13.8. Again, it doesn't say what the lengths are in, so we're going to say units. There, units. All right, so that's that one right there. Number two, we actually happen to have the theorem 716 type 1. We have 2 chords in the circle. Okay, so on this diagram in particular, it kind of is iffy, but M m is this piece right here, and the 3 is this piece right here. Alrighty, so we start by stating that the quantity of 6.5 times m equals the quantity of 3 times 7. And that is because of theorem 7, there goes 17 again, 716 type 1. Let's see if I can write that smaller. Theorem 716 type 1. Oh, a lot better. All right. So that becomes 6.5m equals 21. We divide both sides by 6.5, and we get that m equals 3.23077 because it keeps going. So rounding that to the nearest tenth, that means that m is approximately 3.2 units. And that's that one. All right. And that brings us to the end of this lesson. Very short and sweet. If you have any questions, please feel free to send me an email or find me on Teams. All right. Until next time, guys, have a good one and stay safe.